Okay, welcome back. So now we are going to do a practice quiz. This is quiz 10L. We're going to look at this for a few minutes. We're going to work out some problems. One thing I did want to point out about buffer solutions. Right here, when you're trying to figure out your pH, you've got your pKa, and you're taking the log of the conjugate over your acid here. What we're looking for here is moles. We are not looking for molarity because we may have different volumes of solution. So we really need moles. That's going to become important in part A of this question. Now this quiz is just one question broken into 3 parts. So the first thing that we're going to do is we're going to look at and figure out what our molarity is. So for HQ, which is our acid, we have 0.150 molarity, so that's moles per liter, and then we have 100 milliliters of that. So we're going to multiply that by 0.100, and that's going to give us our number of moles, which if you plug that into your calculator, that's going to give you 0.015 mole of HQ. All right, and then for our NaQ, which when that is in solution, that's going to dissociate to Q minus. We're going to have 0.100 moles per liter, and then we have 200 milliliters, which is 0.200. And then we're going to plug that into our calculator, and we're going to get 0.020 mole of Q minus. So now we have what we can plug in here for our concentrations. We've got our pKa right here, so we're going to plug it into our formula. Our pH is going to equal 4.06 plus the log of, and we got to put our Q minus first on top here, 0.020 over 0.015. And this is going to give us a pH of 4.18. So that is part A right there. Now, we're going to take our results from part A, particularly this part, and we're going to do an ice table for part B. So what is the pH after 0.004 moles of H plus to the solution here that's described in part A? So we're going to do an ice table. And on this ice table, we are actually adding H plus. So we're going to start with Q minus plus H plus, and that is going to give us HQ. All right. Now, if you don't remember how to do an ice table, it's a pain, but it's not super difficult. So you start with your initial concentrations. So our initial concentration of Q minus was 0.020 moles. These all have to be in moles. And then we are going to add 0.004 moles of H plus here. And then our initial concentration of HQ is 0.015 moles. All right, so our H plus here is going to get used up in a reaction with Q, and it's going to come over here. So we're going to subtract 0.004. That's going to leave us with no free H plus floating around in there, which is exactly what it should be. And then we're going to subtract it here too, because this is reacting together. And then we're going to add it here. Okay? So this is going to give us 0.016 as our concentration for Q, and 0.004 0.19 as our concentration for HQ. And we're going to take these new concentrations here and we're going to plug them into our pH formula, our Henderson-Hasselbalch equation. And we're using the same pKa value here. We're just putting in our new concentration values. And remember that it has got to be our conjugate over our acid. So how that's going to look here is it's going to be our Q minus over top of our HQ. All right, which is exactly what it looked like there. It's just you've got different numbers now. And when you run that through the calculator, you're going to get a pH of 3.98. I got 985, which if you were rounding that up, that would be 3.99. Butcher's Key does say 3.98. He did not round up, so take that as you will on that one. And then we're going to take a look at the third part. So what is the pH after the addition of 0.004 moles of hydroxide into the solution? So on this one, since we are adding hydroxide, what we're going to do is we're going to start with our acid over here. Let me get to where you can see. And we're going to have HQ plus hydroxide. And this is going to give us Q minus and water. So our water does not come into play in the Henderson-Hasselbalch equation. It's just kind of there. So we don't really need to put that in, but that's what your reaction is going to look like. So we're going to start with our the quantity, the concentration that was described up here in part A for this. So our acid concentration, if you'll remember, was 0.015, and our conjugate base concentration was 0.020. Now we are adding 0.004 molar of hydroxide. Now, this hydroxide is going to react, so we're going to subtract that back away. And we're going to subtract that away from the HQ because the hydroxide is going to react with our acid. And then we're going to add that over here because when these two react, the water is going to come over here and then the Q minus is going to be added into this part. So when we do our math on that, that is going to give us right here 0.011, 0, 0.024. And again, we're using our same pKa value of 4.06 plus the log of our Q minus over our HQ here, which is over our HQ, which is 0.011. And when we do that math, that's going to give us a pH of 4.398. And if you round that up, that's going to give you 4.4. And Dr. Butcher does round this one up on his key. I am not entirely sure why he rounds this one up, but he does not round this one up. That is a question that we'll have to ask him. If you guys have any questions, please feel free to comment, call, text, send me an email, catch me after class. I hope this made sense. Let me know if you got any questions. Thanks.